Thank you. Today I will be talking about GraphQL and beyond, because GraphQL gives us endless possibilities. I will focus mostly on generating the GraphQL CRUD API. But before we begin, let me introduce myself. My name is Michael. I'm a senior software developer, but I'm also a creator of the TypeGraphQL framework. You can find me on GitHub and Twitter at that handle. Today we'll be focusing on the code-first framework. So a quick recap about two ways of creating the GraphQL schema. The first one is the schema first, when we define the types using the schema definition language. So we have separated the types declaration from our resolvers implementation, and on Bootstrap the server builds the construct and join those two together. But with the code-first approach, we define the types and all the operation using our code constructs. It might be direct or indirect, which I will explain later. So the type definition lives near the implementation, so we have it's easy to keep them in sync. It's mostly usually more flexible, more powerful than the schema first approach. And because of using the code first approach, we create the constructs on the fly during the runtime of the server Bootstrap. So what is the indirect approach? It's basically about the metaprogramming. So we have our code and with some annotation which are providing the metadata for different purposes. Like on the left we see the library for putting metadata about the validation. So we have the DTOs that needs to be validated, and we put the constraints on top of the simple class in TypeScript. On the right we have the current definition of the entity, a table in database. That is also using the decorators from TypeScript as a notation to put the metadata in the right time. So TypeGraphQL is using the same approach about the indirect generating the GraphQL schemas. So we have normal TypeScript classes, but with TypeScript decorators on top of that to inform that the class is the object type or input type. Also the different names of the fields. Because of some limitations of the TypeScript compiler, we need to kind of duplicate the nullable for the optional fields. And the main thing that TypeGraphQL is doing is generating the types that correspond. For example, in this example of class recipe, it creates the object type which corresponds to the type recipe from the SDL you can see on the right. But it's not also for declaring the simple types. It's also for the code field, for the resolvers. So we have the definition of the queries mutation in our normal classes like the services. TypeGraphQL also supports dependency injection using constructor injection. You can also define field resolvers for different types, and also have some built-ins. Capabilities like the out layer built-in or integration with validation frameworks. So in this example, we have the recipe resolver, which is declaring the corresponding to the SDL the type query with recipes operation and remove recipe mutation. The second part of that presentation is Prisma. Prisma is using the schema first approach. So we declare the database shape, the database tables, using the special language they call Prisma Schema Language, with all the annotation about the relation, database constraint, defaults, etc. And just not only creating the mutation, the constructs for SQL, but it also comes with the really powerful Prisma client, which is a service, a library that allows you to query the database in a type-safe manner. So you don't need to write the SQL by hand, but you can use the API that it provides. So the main point of this talk is the TypeGraphQL Prisma, which is joining those two libraries together. What can we say about that tool? It's basically a Prisma integration for TypeGraphQL. It's an NPM installable package, so we can find that on NPM. It's a Prisma generator, so it works like using the workflow and the tools of the ecosystem of the Prisma. But most important information is that this tool generates the GraphQL API based on the Prisma schema, so based on the database schema. So how to use that? We put the generator block in the Prisma schema file. That's the file when we define our models, so our entities. Apart from the standard Prisma client generator block, we need to put the provider TypeGraphQL Prisma. We can also configure the output of the generated source code, because the first important thing is that it generates the source code. It not just creates something in runtime. So what does it do? It translates the Prisma schema constructs, like the user model, and generates the source files, the TypeScript source files, the classes, with TypeGraphQL decorators like object type, field, with all the metadata that it needs to properly build a GraphQL schema, like the nullable false for some optional fields, or nullable true for optional fields, or providing like differentiation between the float or int. But it's not only create the simple DTO classes, it also creates the construct for arguments for the operations, the really complex one, like also the input types, like the where conditions for some queries, the results of some aggregation queries like user count aggregate. But the most important thing is the resolvers. It automatically generates CRUD resolvers so we can easily use all the operations that the database can provide, like reading or updating, abserting, deleting, and also really powerful aggregation queries. And also have built-in like automatically generated relation resolvers, so you don't need to create the field resolvers for the relation by hand. It all comes together. So we can see on the right the user CRUD resolver class with all the type GraphQL decorators like context, args, and we can see that in some technical issues. Okay. We can see that it uses the Prisma from the GraphQL context to execute the operation of the database. And so given that we have the resolvers, the classes, how to bootstrap the GraphQL API from that, we're gonna use the build schema function from TypeGraphQL package. And the TypeGraphQL Prisma integration is generating like the big export file when we have the resolvers export, which is basically an array of classes. So we put that into the build schema, and that's all. The schema, the GraphQL schema, executable schema is ready to use. And one thing we need to remember to make that work is to provide the Prisma client instance in the context of the GraphQL server. In this example, I'm using the Apollo server. So we can jump to live demo or not live because of some technical limitations. I will present you the result of the live demo I've made in home. Here we have the Apollo Studio, which is basically like the Postman for GraphQL. So we can execute some simple queries like to get list of all the users, which is not a bit impressive. The impressive might be that we can query for the post of the user without writing any single line of code. So in this example, we see that we get the ID, email, and name of Alice and the posts, and also have on the bottom the second user, which is Bob. But it's not like only simple queries are available. We can also execute some really complex one, like with the really complex conditions, filtering, sorting. In this example, we have like searching for user that name contains Prisma. We sort that by name in descending order, so we get the Bob user as a first item of the array. And we also fetching the post for that user, but only those with condition like title contains Prisma, and we only take one. Like we had a lot of posts for in the previous example. Here we have only single one for every user in our database. We can also, like the CRUD is for mutation also, so we can create users, we can put the data in the input and get the data back when it's reinserted in the database. We can see from the auto-generated ID that it's really generated and inserted. And also some complex aggregation like group by. So here we are grouping by the post by published flag. And we also only interested in the posts that are created by Alice. So we see that we have one published post and one unpublished. And we saw that we can like mutate, perform some mutation, add some entities to the database, but in real API it might be really like dangerous. So one way of exposing only selected Prisma actions or only selected models, because we don't want to expose the whole database, is that we don't need to only use the resolvers array. We can really import only the things that we are interested in. Like for the user, we have like the full CRUD resolvers, but for post, we are only interested in the find unique, find many, or aggregate queries. No mutation exposed, no dangerous actions can be performed. We can also like customize our schema. So we can, for example, omit password fields, so it won't show in the all the outputs of GraphQL. So it's not possible to leak that information on the server. We can also rename some models from our database under different name in the GraphQL. Also rename the fields. It's not only like the generator grades the source files, and we only can use the things that it provides with all the package, but we also can choose what we want to use and build our own logic around that. So for example, here we have the best user query, which is having all own logic, like finding first user with name, with provided email. But we don't need to write everything by hand. In this example, we are using, for example, the user class, which is automatically generated by the integration. So we have like building blocks, the inputs, the arguments. We can reuse them and compose and create our own logic, our own resolvers, or even we can create custom model fields. So we are not limited by the fields that are in the database. We can create our custom logic like the field resolvers, some logic that will execute when we query for a selected field. And in this example, favorite post is a bit naive implementation because we only have like taking the first post of selected user, but it's only for the demonstration purposes.
I was wondering basically, so when you are generating those CRUD mutations, are you able to overwrite like, part of the execution of the flow? Like if we had to create a user, so I can imagine that we have some like magic building blocks which save the user for us in the database and do like all the logic. But what if we wanted to, add some custom logic to that? Like for example, call a webhook after the user is saved, or do some extra validation before it's saved. So can we do that with this library?
We can. We have like two ways of doing that. The first one is because TypeGraphQL is focused on classes. You can like extend the class and override the method to put some our own logic, call supper, the method name, and put the logic. And also TypeGraphQL has middlewares features, but it's mostly for the infrastructure code, not the business logic. But you can also use that, and with the apply extensions feature, you can like put the decorator, the middleware on top of that method, and to add some more logic. You actually need to validate the input or perform some side effect after inserting to the database.
Okay, so it sounds pretty flexible. Actually, this is something similar to what we do in Graphene, because at Sailor we use like our backend is built in Python and Django, and we use Graphene library. I don't know if you are familiar with this, but it's using similar approach with class-based schema generated from code, basically. So is it like code first? Yeah, that's the name. And we have very similar pattern, but this is not part of the library, but our own implementation where we can also extend some class, and based on that, we are able to generate this mutation. And every step, like every part of the flow, is a method that you can override, like saving to database or validation. So it's actually pretty similar. Sounds good. And can you use this library with, like, because I'm not too familiar with Prisma. I know there are two versions, like Prisma 1, which is pretty old, and I think this was kind of like alpha version.
Yeah, now we have the Prisma version 4, but it's
Okay.
mostly because of the breaking changes being like treated seriously. So even some small changes are causing breaking changes, so they bump the version from 2 to 3 and from 3 to 4. But it's not like a breaking change between the Prisma 1, which is definitely something different
Like a
than the
different
Prisma 2.
Okay.
Prisma 2 is now more like the ORM for TypeScript, and also for Go. They have the Prisma client for Go. But the previous one was like focused on exposing like via the Docker, not by the binary.
Okay.
So now it's like more flexible.
And can you use this library with like the recent version, or you support?
Yeah,
like
it's for the version 2 and then the newer, so 3 and now 4 not yet, because there were some changes in the internals which I'm using for making the generator. But yeah, it's mostly focused on the new version, and I try to keep in sync as frequently as possible. So when they release like in 2 weeks or 3 weeks cycle, a few days later, my version is also compatible with the latest version of Prisma.
Okay. So maybe we have some questions from the audience already. We have one.
Can I actually do two? So the first one is kind of about this weird syntax when you had a provider. What was that path? Because that's just relating to why was it in node modules.cache?
That was just for demonstration purposes, because basically like Prisma client in the beginning was generating like to the node modules. The goal was like different platforms could have like different users, different developers could work on different platforms. Because they are using binary engine, it means that it needs to be compiled on the platform like Windows, Linux, macOS. So it's not like committed into the source code. They choose the path of generating the Prisma client from the Prisma schema into the node modules. So I try to follow that pattern and also emit the source files to node modules. But it's like only the default option. When you compile to put the output, set the output to the node modules, it will transpile the TypeScript to the JavaScript, so you can use it in the JavaScript environment. But if you provide your own path, like in the src folder, it will generate the TypeScript source files instead of the transpiled one.
And it should be safe to commit to
yeah, and then
control.
the source file is the normal TypeScript source file, so you can easily commit that. But it might frequently change because of some...
Got it.
Yeah.
And the second one is, how do you deal with what usually is an issue for me is when you have recursive queries, like let's say user has friends, friends has users, and does the generator in any way handle that, or do you still have to optimize those queries by hand?
In the first version, I was using the data loader by myself, but since I don't know which version, but like 1 or 2 years ago, Prisma built in the data loader into the query engine. So they were like, when you call the Prisma client in different resolvers, they were just waiting for like 100 milliseconds or the event loop cycle to collect all the queries and build a more performant query. It's mostly work for the simple, like the field resolvers, when you have the post and author and some simple stuff. But there's also a really interesting library called Prisma Select, which is parsing the GraphQL resolve info tree, so the information about the query, and translate that to the Prisma client API, the object for the Prisma client, so for the query. So it can really put the select for only selected fields, and create really optimal query. And I am also exploring this approach, but yeah, it might be under the flag, the configuration option in generator block. Because like if it be the default one, then all the custom queries will also need to use that, because for the field resolvers which are using the normal Prisma query, you can like having a simple logic in the query or in the mutation, return the data, and everything is working. But with the approach of skipping field resolvers, so having not lazy resolving of the relation, but ahead of time on the main root query, then it's like spreading all over the other queries, so they need to be compatible. So it should be like done under the flag to not break any existing apps.
How do you use Prisma inside your integration library? Do you use their binary, or do they have source code or API for the cloud, or you just call the binary comments?
Prisma engine is like talking to the database when you put the connection URL in the Prisma schema file. So the query is the engine is binary to allow, it's written in Rust. So the goal of the Prisma was to be multi-platform but fast. So it's not like they having the previous version was having the Scala version in the Docker, so it was really slow. This one is having like the compiled binary written in Rust and bindings, so the exposing the API, the Prisma client for TypeScript and JavaScript, and there's also a version for Go. I'm not sure if there are more, but maybe there are some open source projects by the community for different language. I'm not sure if I answer your question.
Of course, thank you. Is Prisma code open source right now? The code that compiles into the binary.
Yeah, I think the Prisma is open source. They have like the Prisma data proxy is basically the software as a service for handling the connections limitation for the Postgres, for example, like the pool of connection, managing that. So they expose like a wrapper, and this one is for now paid. But the root library is for now open source and then free to use for even commercial projects.
Okay, thanks for your questions. You just earned t-shirts, so yeah, don't be afraid of asking questions. Unfortunately, we need to do a 5 minutes break because like we need to restart everything. We had a little trouble, so I'm afraid we need to end the presentation here.
I can finish from my head.
It's if you want.
Because basically the last slides were about the recap what with TypeGraphQL Prisma integration, which we basically define here in the Q&A section. So it's a library that automatically generates the GraphQL CRUD API from our Prisma schema. And allows not only to quickly bootstrap the project by using the resolvers array, so we can define the data model and quickly run the project, the server in 5 minutes. But it also allows for a lot of customization and configuration for our own needs. So it's quite flexible and can be used in even more complex projects. And also, because it's generating the source files, it's also always possible to make an escape hatch and like skip the generator, use the generated source files, modify that indirectly in the result in the methods if we even need that. And yeah, I wanted also to talk about the future of TypeGraphQL, because our panel will be about the GraphQL. The things in the future. So basically, we saw on the slides that there's a lot of boilerplate, a lot of like noise because of the decorators, and that's all because the TypeScript reflection system is a bit limited. It was written a really long time ago, mostly for Angular 2, for the dependency injection, and since that time it haven't evolved into something more sophisticated, like in other languages like Java or C#. So basically, my goal is like to create my own version, like my own TypeScript compiler plugin, so I can read the abstract syntax tree, read that all the types metadata, and emit that in the generated JavaScript files, so that the TypeGraphQL framework can read the more enhance the definition from that, instead of relying on manually providing the information like the nullable true or the type in the decorators. So the syntax should be really more clean. Okay, so that would be all. Really thanks for your attention. We had questions already asked, but maybe someone have more questions. I am free to answer.
Hello, Roman Prohachenko, Alex. I would like to apologize in advance. I'm really new to GraphQL, and I'm really far away from JavaScript and TypeScript and all that something scripting languages. So what I saw is that it's really good to bootstrap a new service. Like you define a schema, you get most of the stuff auto-generated. But my question about how to operate a service in the longer run, when you do have more and more business logic applied to a service, which could be problematic to fit into the resolvers and keep the code still readable. Or another idea is that I have seen multiple times in my experience that sometimes there are some objects that are moved out to some other services. Like for some time, as a startup, we may have some user management on our own. Then we want to use, for instance, Cognito or something else to store the users, and we want to move them to other services. How do we? But we still have to keep that API layer consistent, so we don't have multiple services in the microservice environment that will suddenly have to change the endpoint they ask. So how do you think you can handle these two cases? One of them is adding more and more business logic to the service and not keeping everything inside in one place in the resolvers, or moving out an object to a different data source, different service. Thank you.
I think for evolving, like when we start with the simple project on the bootstrap phase, when we really want something to be exposed at the beginning, we use the resolvers already auto-generated, but then we can pick which resolvers we want to expose, like full capabilities, full CRUD capabilities for the user, but only some selected actions. So we may only stick with the aggregation queries or the simple find many with the complex conditions, and having all the mutation or the creating and updating, upserting with our own resolvers. So we only can, for example, in the basic scenario, we can reuse the object type, the return type of the mutation, for example. But we can also use the inputs, selected inputs, so we can compose our own payload, our arguments for the Prisma client query, and like by adding more logic, we have more custom resolvers. We remove something from the import of the auto-generated one, which are maybe too powerful or leaking some information. So we can like combine our own resolvers, which are using our own logic, with some like code blocks from the generator, like the arguments, the classes, but also having some other parts using the generated resolvers for simplicity. So we can like gradually evolve towards only using like custom business logic, custom resolvers with the simple help of the arguments of the inputs, the classes generated, the simple blocks from the TypeGraphQL Prisma integration.
So as far as I understand, you can use these custom resolvers to, for instance, replace queries to a database for some objects to another service, right?
Yeah, you can combine them.
Thanks.
Okay.